In this video, we are going to talk about the nodal analysis. So, let's talk. What is a node? Node is formed by an electrical circuit by two or three wires. Let's hope this is a node. And we can easily find, let's take as this an electrical circuit, and here we can find that it is a node, 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 it is a node. So is this it is clearly what is a node. Step for solving. So when we try to step for solving using nodal analysis, first we need to select the reference node. So first we need to select the reference mean we need to put where V is equal to 0, where volt is equal to 0. That's called the reference node. And then we need to put the node voltages like V1, V2, V3, and then Vn. What do you like? How many nodes you can put? How many that V1, V2, V3 from your node according to your node. And the third is apply KCL rule. Apply KCL rule. What is KCL rule? Kirchhoff's current law. Kirchhoff's current law. That's KCL. That's it. When we apply KCL, after that we can go to the answers. So these are the three steps. So please don't forget how we can do that. Let's take an example. It's an example using nodal analysis. Find the node voltages. So what we gonna do? First we need to put the reference node. So where is the reference node? I took this as my reference, that is equal to 0. So is equal to 0 means the whole line is equal to 0 because there are no source here, voltage source or current source. Then I take V is equal to 0, V is equal to 0, V is equal to 0. That's it. After that you need to put the voltages from the node V1, V2, V3, however you like, VA, VB, VC, VX, VY, VZ. You just put it here. I put it here V1, and here if this is V1, this is also V1 because there are no voltage drop here, and here is V2, and here also it is V2, there is no voltage drop here. So then we need to put the KCL. Before putting KCL, we need to put the current through the line. Just what you like you can put. Just follow me. This is I1. You can put reverse order or other order. You can put IA, IB, IC, what you like. But I put this is I1, and here I2, and here I3. Here is equal, here 6 amps. So I don't change this. Then here if it's I3, here also I3, and here I4, and here 3 amps. So here 3 amps. So that's it our first part. Then we need to do our KCL. So what is the first step? First we need to do that. Apply KCL to node 1. Where is the node 1? Here is the node 1. So what is Kirchhoff's current law saying? In the node, incoming currents is equal to outgoing current. So incoming currents are I1, only I1. So I1 is equal to I3 outgoing plus I2. Sorry, I1 and I2 are incoming currents, and the outgoing currents are 6 and I3. So for I1, what we gonna do? For I1, here, for we know V is equal to IR. That means I is equal to V by R. So I is equal to V by R. We just put the voltage different, then the resistance. So for I1 here, what is the voltage difference? V0 minus V1. For I1, 0 minus V1 over 10 ohms plus I2. For I2, what is the difference? 0 minus V1. 0 minus V1 over the resistance is 5 ohm is equal to 6, and that's no change. 6 plus I3. What is the I3? The voltage difference V1 minus V2. V1 minus V2 over 2 ohms. Right. When we solve this, we have to come this V1 minus 5V2 is equal to 60. This is our first equation, and there are two unknowns V1 and V2, so we need two equations. So I just put the KCL to node 2. So apply KCL to node 2. So what is the results for that? Here our incoming currents is equal to outgoing current. So incoming currents are I3 plus 3 amps plus 6 amps is equal to I4. So 9 is equal to I4 minus I3. So 9 is equal to, for I4, what we gonna do? I4, the voltage difference, V2 by 4. V2 by 4 minus I3. What we gonna do for I3? I3 V1 minus V2 by 2. So when we solve this, we have to come this minus 2V1 plus 3V2 is equal to 36. And it's our second equation. So when we solve this, we need to come, you can use a calculator or Cramer's rules or simultaneous equation. What we gonna do? The answer, if we come, I'm using the calculator, what we can see, what we gonna do, V1 is equal to minus 90 volt and V2 is equal to minus 48 volt. That's our answer for this. So this is the first example for using nodal analysis to find the node voltage. Let's take in another example. So here it is. Find Ix. So we need to find the Ix using nodal analysis. So find Ix using nodal. First, what we gonna do? We need to put the reference. So I take this as reference. V is equal to 0. So this also V is equal to 0. So this also V is equal to 0. Then what we gonna do? We need to put V1, V2, V3. So I'm starting in here. This is V1, this is V2, this is V3. But this is not our question, V1 or V2 or V3. Our question is Ix. Find I. When we find V1 and V2, we are going to Ix. That's our step. So next step is we need to put our currents. So in this node, here it's 3 amps, here Ix. This is empty, so I put I1, and if the I1 goes here, here also I1, Ix, I2 and I3. So here also I3 and Ix. That's so we gonna put applying KCL to node 1. So node 1 is here. So KCL means incoming current is equal to outgoing current. So incoming current is 3 amps is equal to I1 plus Ix. So 3 amps is equal to I1 means V1 minus V3 by 4 plus Ix means V1 minus V2 by 2. So when you solve these, we came to an 12 is equal to 3V1 minus 2V2 minus V3. It's our first equation. So 3 unknown, we need 3 equations. So first equation, then we go to second equation. Applying KCL to node 2. So what we gonna do? Node 2 here, what are you gonna do? Incoming currents is the IX. IX is equal to outgoing currents are I2 plus I3. Ix is equal to V1 minus V2 by 2. I2 is equal to V2 by 4 plus I3 is equal to V2 minus V3 by 8. So when we solve this, here is V1 minus V2 by 2 is equal to 8. 2V2 plus V2 minus V3. So 4V1 minus 4V2 is equal to 3V2 minus V3. So when we solve this, 4V1 minus 7V2 plus V3 is equal to 0. That's the second equation. And we need to get the third equation. So put the KCL at node 3. So applying KCL at node 3. So it will give us incoming currents are I3 plus I1 is equal to 2Ix, the outgoing current. This is a dependent current source. It have the value of 2Ix. So when we solve this for I3, V2 minus V3 by 8 plus V1, I1 for I1, V1 minus V3 by 4 is equal to 2. For Ix, I don't have any space here, so just I Supernode and then 2 for Ix, V1 minus V2 by 2. So it is our third equation. When we solve this, we came to a conclusion for this answer. V1 is equal to 4.8 volt, V2 is equal to 2.4 volt, and V3 is equal to 2.4 volt minus 2.4 volt. I'm using calculator. What are you gonna do? So Ix is equal to V1 minus V2 by 2. So when you apply these values in here, we come Ix equal to 1.2 amps. That's it. So here, what we gonna talk about the next step is, what is supernode? Supernode, if a voltage source is connected between two non-reference nodes. So it is two non-reference nodes. That means like this. If this is a voltage source and it's connected between two non-reference nodes, it's non-reference node means the node voltage doesn't have a zero value. It must have a value plus or minus. That's the non-reference node. Nodes from a generalized, we call that as a supernode. So when you saw a voltage source in a nodal analysis, you need to analyze that is supernode or a normal node. So let's take an example. In here, this is the question. 10 volts and 5 volt, 8 ohm, 6 ohm, and here V1, V2, V3, 4 ohms. The question is, find the node voltages V1, V2, V3 using nodal analysis. So what we gonna do using nodal analysis? Find the node voltages. So what we gonna do here, the two voltage source. So what we gonna do? Whether we check that whether it is supernode or not. Let's take this. This is connect between this and this. So this is reference. V is equal to 0. That's this also. V is equal to 0. V is equal to 0. So this voltage source connect with, is this voltage source connect between two non-reference node? No. This is reference node. So this is not supernode. So let's take this. Is this voltage source connect between two non-reference node? Check it. V2, V3. Yes, this is supernode. So what we gonna do? We put nodal analysis to supernode. So we put nodal analysis to supernode. Before that, we need to put I1, I2. What you like? You can put I2 here or I3 here. That's not problem. I3 and I4. That's randomly I pointed that. So before that, we know in here V1 is equal to directly 10 volts. V2 minus V3 is directly 5 volt. So what we gonna do? We need only one equation before to solve this, because there are three unknowns, v1, v2, v3. So we need three equations, but we already know two equations. Here is three equation. Apply KCL to supernode. So in here, what is the KCL? I1 plus I2 plus I3. Before, three currents are incoming to the supernode, and I4 is the only current going out from the supernode. For I1, what we gonna do? I1 V1 minus V2 by 2 plus I2. What we gonna do? 0 minus V2 by 8 plus I3. What we gonna do? V1 minus V3 by 4 is equal to I4. I4 is V3 by 6. So when you solve these three equations, we came to the answers V1, V2, V3. So V1, I'm using the calculator. V1 is equal to 10 volt, V2 is equal to 9.2 volt, V3 is equal to 4.2 volt. That's it. That's these questions from the node voltages. The other video comes from the mesh analysis. Please subscribe.